Problem 5. Consider the function f(x) equals square root 1 plus 2x. Find the derivative using the definition, then domain of function and domain of the derivative function. First, let's worry about the domain of the function. This is a square root function. So the object inside must be greater equal 0. That is 2x. I'm sorry, that should be plus 2x should be greater equals negative 1. The 1 goes over there, becomes negative 1. So I'm going to be dividing both sides by 2. X has to be greater equals negative 1 over 2. So x has to be greater equals negative half. Alright. So x has to be greater equal negative half. That's the domain. Now let's figure out the derivative. By the definition, f prime x equals limit h approaching 0, f of x plus h minus fx over h. What do? I plug in x plus h for x. Okay, don't forget to use parenthesis. Square root 1 plus 2, parenthesis x plus h minus fx is square root 1 plus 2x. So this is classic radical expression. When you have a negative radical expression, you are looking for its conjugate. So negative here, positive here. I multiplied the numerator and denominator by the same conjugate. Okay. What's the purpose of this conjugate? Well, that results in difference of squares. Difference square of the first term and square of the second term. Denominator as it is. When I take square of square root, they go away. Square of square root, they go away. So 1 plus 2 times x plus h, that's good. Minus, don't forget parentheses because this is an expression. That's a commonly made mistake. Remember to keep things in parentheses when you square. So that minus distributes. And here the 2 has distributed. Okay, no change in the denominator. Now you can cancel things. So notice 2h survives. 2h upstairs, h times something downstairs. So h is cancelled. So 2 over that something. Alright. So when h approaches 0, this term goes away. So I'm left with square root 1 plus 2x plus square root 1 plus 2x. That is 2 times square root 1 plus 2x. 2's go away, 1 over square root 1 plus 2x. Okay. 1 over square root 1 plus 2x. Alright, so that is your derivative. What about the domain of the derivative? Look, here again, x has to be greater equals negative half, same argument, but x cannot be negative half. So it's basically the same argument as here. Let me copy and paste so you will see. The only catch here is I cannot be equal 0, so it should be strictly greater than. I cannot have the denominator to be 0, so the object inside must be greater than 0. Subtract 1, divide by 2. Okay, so you want x to be greater than negative half. All right. Next, f of x is 5 plus x over 1 minus 4x. Same questions, right? So this is, let's expand it. So zoom in a little bit. So now what about the domain? First, for the domain, what do we want? The denominator must not be equal to 0. All right. So that means I'll move the 4x to the other side. 1 must not be equal to 4x. Divide both sides by 4. You get 1 over 4 is not equal x. Alright. So x should not be 1/4. So all real numbers except 1/4. So that's the domain of fx. Now derivative. So derivative, limit h approaching 0, f of x plus h minus fx over h. F of x plus h. I will put in x plus h for x. Don't forget to use parentheses here because you're multiplying by 4. Okay. For good measure, if you use upstairs, no harm done. Minus fx. Fx is this quantity. So that's a fraction, subtracting fraction. So you need common denominator. That factor times that factor. Okay. So I need for the first fraction to multiply by 1 minus 4x. Upstairs, downstairs. Minus. The second fraction I need to multiply by this factor. Upstairs, downstairs. Okay. Now I have common factor, a common denominator, I'm sorry. So that's in the denominator. Now I need to simplify this. This minus this. All that is written. Look at the denominator. I'm writing h as h over 1. Why? Because now I can see that that's a fraction over a fraction. Division by a fraction is multiplication by the reciprocal. You see, h over 1, I'm taking its reciprocal. I'm going to multiply that to the numerator. So numerator is here. Notice I am now distributing 5 minus 20x plus x minus 4x squared plus h minus 4xh. So the first part was good. Minus, you multiply the same way, but remember this is a subtraction. So whatever you multiply it out, remember to keep it in parentheses and then distribute the signs. Once you do that, you will see that things cancel, and in fact only 20h and a 1h here and 20h they survive. Alright, so that's the numerator. Denominator I have not changed anything, and I have 1 over h, this 1 over h, and that h cancels this h. Alright, that got me 21 upstairs, this denominator as it is. Now if I let h approach 0, that's the only place h exists. So that goes to 0. I have 1 minus 4x and another 1 minus 4x. So the factor 1 minus 4x power 2 in the denominator, 21 upstairs. So the derivative is 21 over 1, oh there you go, 1 minus 4x quantity power 2. Now what about its domain? Well, its domain is the same as the previous guy because all you want is denominator to be not 0. Okay, so denominator should not be 0. Simplify, simplify, you get x should not be 1/4. So all of these, all real numbers except 1/4. Next, fx equals 1 over x squared. Same question. What's the domain? Domain, x should not be 0. That's all. So all real numbers except 0. Okay. Now, f of x plus h minus fx over h, limit h approaching 0. F of x plus h is 1 over parenthesis x plus h squared minus f of x 1 over x squared. Alright. You need common denominator. So this times this. So I need an x squared here, so x squared upstairs minus I need x plus h quantity squared here, right? So that's the amount I multiply upstairs and downstairs. Now that I have common denominator, I get them together. X squared minus x plus h quantity squared. This little h in the denominator, I have written it as a fraction. As always, why? Fraction, division of fractions is multiplication by the reciprocal. Okay, reciprocal. So, numerator. So that can be expanded, and because of that minus outside, remember to place it in parentheses. Okay, once you do that, open the parentheses with the subtraction, and you see things get cancelled. Only the h terms survive. Well, get h common. You have negative 2x minus h. Denominator no change, and there is 1 over h. That h cancels this h, and you're left with negative 2x minus h over this quantity. Now let h approach 0. That goes to 0. So you're left with x squared and an x squared in the denominator. In the numerator, that goes to 0. You're left with negative 2x. Look at that. So there are 4 x's here, 1 x above. Cancel one of the x's. Negative 2 over x to the power third. Okay. What's the domain of that? Well, x cannot be 0. That's all. All real numbers except 0. All right. So, problem 8. Match the graph of each function with the graph of its derivative. All right. So this is a big question. So let's go through each one. This one, I look for slope 0 there and there. So what's that? That's at say 1.5 and negative 1.5. So you want the derivative to hit x-axis at 1.5 and negative 1.5. That's the one. Okay. So that's 1. So for A, it is 1. All right. For B, all right. For B, this is a line, so it has constant slope. There is no slope here, no slope here. So what's that? 2 and negative 2, there is no slope. This looks like a constant to the left, constant in between, and a constant to the right, and no slope at negative 2 and positive 2. There you go. No slope at negative 2, positive 2. No slope, right? Constant to the left, constant to the right, constant in between. So 4 is B. All right. The next one, this one. Horizontal tangent there, horizontal tangent here. But what's happening? It is decreasing to the right, increasing to the left. So to the left of 0, it should be positive. To the right of 0, it should be negative. Okay. To the left of 0, it is positive. To the right of 0, it is negative. So that's this guy, 3C. Okay. So what's left over? Only this, I suppose. 0, slope 0 there and there. So there are 3 places where slope is 0. Okay. Here it's increasing, so my graph is above x-axis. Here it's decreasing, graph is below x-axis. Increasing again, graph is above x-axis. Decreasing, graph is below x-axis over here. Okay. So D is 2. What's the matter? Looks like internet is slowing down. Anyhow, so I will stop the recording right now so that I don't lose time on this. Okay, next problem will start in the next video. Until then.